12 grams of carbohydrates, and 2 grams of protein. Per ounce. Type 1 cost 20 cents per ounce. Type 2, let's see, 8, 12, 2. Food type 2 has 12 grams of fat, 12 grams of carbs, and 1 gram of protein. And it costs 30 cents an ounce. Each rabbit receives a daily minimum. So this is minimum. A daily minimum of 24 grams fat, 36 grams of carbs, and 4 grams of protein. But get no more than, they eat no more than 5 ounces of food per day. How many ounces of each type of food should be fed to each rabbit daily to minimize cost? I don't care if it's good tasting food or not, we are interested in minimizing cost. No, it's healthy. They're getting no more than 5, we're not overfeeding them, and they're getting all of the fat, carbs, and protein that they should get. So it is healthy. We need to create a system of equations. What do I know about my fat? First of all, I'm going to call this X, I'm going to call this Y. Type 1, type 2. What do I know about the fat? That is the minimum amount of fat they can receive. Therefore, 8X plus 12Y is greater than or equal to 24. Are we okay with that? 8X plus 12Y is greater than or equal to 24. Well, what do I know about the carbs?
12x, 12y.
12X plus 12Y greater than or equal to 36. What do I know about protein? 2X plus Y is greater than or equal to 4. I'm not touching the cost because that is the objective. Minimize cost. We deal with that at the end. What else do I know? No more than 5 ounces of food. All of X and all of Y add together to be what? X plus Y is less than or equal to 5. Are we allowing the rabbits to overeat the X, regurgitate it, and then go over to eat the Y like the Romans would do? If that's the case, we've got a domain and range restriction. X has to be greater than or equal to what? We're not allowing them to return any of the X. It must be greater than or equal to 0. And Y must be greater than or equal to 0. There's your system of equations.
Can you explain that again?
We are not allowing our rabbits to return some of the X so they can eat more Y.
Mm-hmm. So it's just
So whatever they eat stays in their system.
okay.
It can't be negative. Yes?
I just want to clarify, X and Y, they're representing the ounces of each type of food.
That is correct.
Because it's 8
grams per ounce.
Per ounce, yeah, okay.
And 20 cents per ounce. Okay, I'm going to rewrite these in slope intercept. I will rewrite this. That is, let's see, 12y equals minus 8x. Let me keep as an equality, greater than or equal to minus 8x plus 24. Divide by 12. I have y greater than or equal to minus common factor of 4, 2/3 x plus 2. Is there questions on what I did on that one? I could divide everything here by 12. Subtract the x. Y greater than or equal to minus x plus 3. That's this one. Y greater than or equal to minus 2x plus 4. That's this one. Y less than or equal to minus x plus 5. That's this one. X is greater than or equal to 0. Y is greater than or equal to 0. There's my system of equations. Questions? I need to graph that. Y, X, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Y is less than negative x plus 5. That's going to go from 5 to 5. Has a slope of negative 1. It is below because it is less than. Y equals minus x plus 5. Graphing this. 4. That has a slope of negative 2. I can go down 2 over 1, down 2 over 1. It will go from here to here. That is y equals minus 2x plus 4. It's above. This is below. I'm using this region right here. This one goes from 3 over to 3. Y equals minus x plus 3. It is greater than, so it's above. So now I'm using this region right here. This one starts at 2, goes down 2 over 3. That is an irrelevant line because it's not even in the feasibility region. My feasibility region is right here. Is there questions on what I did?
How do you know that's your feasibility region?
Because I started here, I have less than goes here. These are greater than, they're above. I'm greater than the y and greater than the x, so it's this shaded region right here. Here's my graph.
What did you do on the 2? I mean, yeah, oh yeah, you did 2, and it's a negative
2,
yeah, and then
down 2 over 3,
Yeah.
but because that doesn't, it touches the feasibility region right here, it's not relevant because it's greater than, but so is everything else. Okay? Objective equation. I want to minimize costs. For every ounce of X, it costs 20 cents. For every ounce of Y, it costs 30 cents. So, cost equals 0.2X plus 0.3Y. I need my critical points. I have a critical point right here at 5, 0. I have a critical point right here at 3, 0. I have a critical point right here at 0, 5. I have another one right here at 0, 4. And I have my last one right here
one in between.
Yeah, how do I find that intersection right there?
Set the two lines equal to each other.
This line is this, and that has to be equal to this line, which is this. Minus 2x plus 4 equals minus x plus 3. If I add 2x to both sides and subtract 3, I have x equals 1. If x equals 1, I could plug in 1 right here. Minus 1 plus 3 is 2. Minus 2 times 0 plus 0.3 times 5. Minus, let's see, 0.2 times 0, 0.3 times 4. That's going to be cheaper than this. 0.2 times 1 plus 0.3 times 2 I got to look at. 0.2 times 3 plus 0.3 times 0, or 0.2 times 3, 0.5, 0.3 times 0. This will be cheaper than this. So really I need to look at these three. That's $1.20. 20 cents and 60 cents, that's 80 cents. That's 60 cents. What do the rabbits get? 3 ounces of X, type 1. There, healthy rabbits, minimizing my cost. Questions?
It's a minor one, but do we have, don't we have to